Hey everybody, Mr. Quick here. Welcome to Eureka Math / Engage New York Math Module 5, Lesson 5, the area of polygons through decomposition and composition. When something decomposes, like for example, if you throw a banana peel in the trash, it starts to decompose, starts to break down, starts to stink. Composition, just like you have a composition notebook, is when you're creating, right? And putting things together. So we're going to look at some different polygons, and we're going to find the area of these polygons. But the big key is being able to break down these shapes. It may not be your typical rectangle, triangle, whatever, but breaking them down into shapes that are more manageable and that allow us to solve for the area in an easier way. Okay, so we're going to start off with an example here, and this is kind of a unique shape, kind of a horseshoe type shape, or I don't know what you'd even call it. Kind of looks like a magnet. But what you see is it would be difficult to find, or it may look difficult to find, the area of this shape because there's not a rule for this kind of shape. But there is a rule for the shapes that make up this shape, or there are rules for the shapes that make up this shape. And so there's different ways that we could actually break down this shape. I'm going to go through just a few of them, and you may be even able to find ones that I didn't notice. So what we could do is we could cut it right here, and we could say that, again, we know this is 7 meters. This side, we know this whole side is 9 meters, and then if you have to take away this portion here, which is the same as this portion here, so 9 minus 4, so you'd end up with 5. And then here, we know this is 4 and 2, and then this would be 4 and 2. So we can get rid of that for now. And so we can just find the area of this, the area of this, and the area of this, add them all together, and you have the area. Another way we could do it would be to extend. That's not very good. Extend this line here and extend this line here. So basically you have 3 different rectangles. You have a 9 by 2. You have a 9 by 2, because this would be 9, right, as well. And then in this space, I'm going to use red so we can see it a little easier. There we go. In this space, the whole thing is 7, but if you take away this, which is the same as that, 2, and you take away that, and that's 2. So if that's 2 and 2, that's 4, 7 minus 4. This then becomes 3. And then this would be 5, because this portion of the 9 is 9 minus this section, which is 4. So then you find the area here, find the area here, find the area here, you add them all together, and there you go. Another way you could look at it would be to, look at this shape here, and you've got a rectangle here, and you have a rectangle here. So it's just a matter of, I'm not going to break that one down, but it's just a matter of breaking down the shape and finding out easier ways to, when you have an unfamiliar shape, to look at what familiar shapes make up that shape, and then you can use the rules for those shapes. All right, let's go ahead and solve this one. All right, I'm going to use this method here. I'm going to look at this as a shape. I'm going to look at this. That wasn't very good. I'll use a different color. Look at this as a shape, and I'm going to look at this as a shape. And we'll call this one shape A. We'll call this one shape B, and we'll call this one shape C. So let's look at shape A to begin with. So we know this is 2, and then we want to know what this side would be. Well, if this whole thing is 9, and then this side is 4, right? Well, these are the same, so that would be 4 meters. On shape B, they already have both listed for us, so that's good. We have 2 meters by 4 meters. And then for shape C, this is 7, so we already have that. 9 is this whole side, so we know it's not going to be 9. But if this is 4 right here, you take that out of it, then this side and this side would be 5, because you take the 9 minus the 4. So we have our 3 different shapes. For A, we know since these are rectangles, we're looking at base times height, right? So we have it's 2 times 4. So for A, we get 8 meters squared. For B, we also have 4 times 2. So we're going to have 8 meters squared. And then for shape C, we have 7 times 5. So that's going to be 35 meters squared. Now, the key is when you're all the way done, we're looking for the area of this whole thing. So all the parts together. So we're going to add them up. So we have 8 plus 8 plus 35. 8 plus 8 is 16 plus 35. We're going to end up with 51 meters squared for the area of the entire shape. All right, let's look at another example. Here we have a parallelogram, right? These 2 sides are parallel. These 2 sides are parallel. 2 sets of parallel sides, parallelogram. This doesn't exist. They're just showing us the height. And what we can do here, again, looking at what shapes we can actually create, if we split this, we essentially have a triangle here and a triangle here. I'll do a different color so it's a little bit more obvious. So by splitting it, we have 2 triangles. And now we know that the area of a triangle is 1/2 base times height. So we'll call this triangle A. We'll call this triangle B. Really, we should say this is triangle ADC, and this is triangle ABC. So I'll label it A and B just to make it easy right now. So for triangle A, we have a height of 4 and a base. If this is 6 here, right? Sorry, there we go. Then this would also be 6 because of the same length. So we end up with 1/2 6 times 4. 1/2 of times 6 is 3. 3 times 4 is 12. So we get 12 meters squared. But then we also have this other triangle. So for triangle B, we have 1/2. The base is 6. The height is also 4. And so same problem, right? 12 meters squared. And then we have to put them back together. So add them together and we get 24 meters squared. Okay? Let's do one more. Looking at this one, I also see some triangles we could make. You could go across this way, or you could go across the other way, right? It doesn't really matter because the space inside is going to give you, it's the same no matter what. It's like, again, kind of like cutting up a pizza. You can cut in, if it's a giant circle pizza, you could cut squares, stars, slices, whatever you want out of that circle. As long as you don't eat any of it, it's the same amount of pizza, just chopped up differently. So here we have 2 different triangles. We have a triangle here, and we have a triangle here, right? So we know, again, area of a triangle is 1/2 base times height. For for ACD, so this triangle, we'll just say triangle ACD, we have 1/2, and then the base, now if you notice, the base would be 4, right, because that's where we would have our 90-degree angle. Base would be 4, and then the height would be 5. So 1/2 times 4 is 2, times 5 is 10. And then for triangle ABC, we have the base of this one is 8. So we have 1/2 times 8, and then the height is also 5. So 1/2 times 8 is 4, times 5 is 20. So if we put our 20 and our 10 together, we're going to have 30 meters squared. Area equals 30 meters squared. Okay, so we're going to stop there, but I just wanted to give you those examples, and we'll talk about this more in class, face to face, and hopefully we'll look at some different ways we can cut some of these shapes up and help them make sense to us. Thank you for listening, thank you for watching, and we'll talk to you soon.